So the next thing is how do we test these things? We've gone through and talked about some of these testings throughout the week. And, the testing is super important because, if you're going to actually go through and take the time to make these things come to life, like these apps come to life, then you obviously got to test it, especially if there's money involved, right? If we're doing transactions and those transactions have, consequences where somebody's putting in money and typically, with the APIs, typically what these vendors will do is they'll run a 1 penny transaction whenever you're testing. That's usually what the baseline is. And so, whenever we're integrating with any of these third-party vendors that are out there, that's usually one of the litmus tests at the final stage. But, we get into the white box testing, the black box testing, the gray box testing. In addition to that, we would do static source code analysis as well as dynamic analysis. And, whenever we're talking about software testing, this is a part of the development process that, in large organizations, it needs to be thoroughly tested, right? And we typically will do what's called a reasonable test. What is reasonable for any type of things that we're testing? So why do we do that? Well, hopefully we're practicing our due diligence, trying to detect things, right? Remember, that's what we were trying to, but also then going back and making sure that everything is corrected in a way, practicing due care. So check it out. One of the examples in your book that it goes and talks about, it says an example of this reasonable test here is a routine, like a method or a function within a program that calculated optimal weight for a human is being returned a value of 612 pounds. Let me read that again. A routine or a function that you wrote, so in object-oriented programming, right? You go through and you create this function, and it returns a value of for a normal weight of a human of 612 pounds. That would absolutely fail the reasonable check, right? And the reason why I say that is because those are the types of checks that we would do. We would also need to do some sort of unit testing, input validation testing, incorrect types, like is it numeric, alphanumeric, those kinds of things. Do we have any boundaries, or is it out of range? Are there certain limits that we want to be able to do? In addition, we might do some sort of stress testing in a way that's meaningful. With the white box testing, we're going through and line by line analyzing each program of the code. Man, what a hot minute that's going to take you to do. The black box testing will actually, you don't have any access to the internal code. All you do is you're testing everything from the outside. We actually did that for a company over in Madison, which is about 4 miles away from Huntsville here. They created FIPS 140-2 processors for gas pumps, and so they're end-to-end encryption for whenever you put the credit card in at the gas pump, sending it out to the internet. And so we did some black box testing on that, and that was about 4 or 5 years ago, like right during COVID. And that company, after they fixed some of the things we found, about a year later they ended up getting bought, which is they had a pretty cool technology. In addition to that, the gray box testing is a way that we can validate software. And what we do there is we look at, from a user's perspective, and we take a look at the inputs and outputs from a user's perspective, and to see if everything kind of passes the sniff test. In application security, especially for web applications, we want to make sure that it passes the static and the dynamic testing, and from that, usually static would give a chance for things like YASCA that I just talked about earlier, a source code analyzer to try to detect or scan using like basically a find function or a grep function to detect keywords or software flaws. Like if there's known bad functions that people use in different programming languages, we go through and check them. And you do that during the design, during the build, during the testing process. When we first started implementing the software assurance components for the Army, 10, 12 years ago, it was difficult. It's been difficult to build it into the process or bake it into the process. And so a lot of those we would be coming in and bolting on the solution at the tail end. We'd get 1,500 to 1,800 different bugs that we found using static source code analyzers, to the extent that when we found the bugs, there wasn't any more funding left to go and fix the bugs, and so that would be the thing that would be holding up the ATO for that particular piece or release of software. Is we found 1,200 bugs and there's no more money, so they had to go get some more money to fix those bugs. In addition to that, you can also do this thing that's called dynamic testing. And what that'll do is that'll look at the code in runtime. So the code is built and it's actually running. And when it's deployed, we can actually go in and test it. You don't have access to the underlying source code in the dynamic testing. It's more about you're looking for things like cross-site scripting or SQL injection. It could be done in a production environment, but usually it's not, because you don't want to interrupt the service for that. But proper ways that we typically will do testing is making sure that is integrated into the software development processes.